Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. Today I am going to explain about the instruction set of 8051, especially program branching instructions in 8051. This video is a part of series microprocessors and microcontrollers. So the today's presentation, overview of today's presentation is what are the instruction set and how many types of instructions are divided in 8051, and especially what is the branching instructions in 8051 and the two types of branching instructions, conditional branch instructions, unconditional branch instructions, and let us see one program using all these instructions. So coming to the instruction set of 8051. So based on the operations performed, so the instruction set of 8051 has been divided into 5 types. The first one is data transfer instructions, which move instructions, how the data will be transferred through the registers or through the memory to the registers, like. And the arithmetical instructions, how we will calculate addition, subtraction, division, multiplication, all these operations, increment, decrement, everything. So coming to the logical instructions, how we will shift the data or how we will rotate the data and how to perform AND or complement logics. So the fourth one is Boolean or bit manipulation instructions. How to manipulate a bit by using these bit manipulation instructions, how can we perform the programs. And coming to the last one, the program branching instructions. So here, in today's presentation, we will see what are the branching instructions, how these branching instructions are used in 8051 processor controller. So coming to the branching instructions, these instructions are used to control the flow of execution of the program. So, or these can change the sequence of the program. So, if we are performing one program, if there is 100 instructions in that program and the 10 instructions, the instruction, how the controller will process the program means it will do with the sequential process, first instruction, next instruction, like that. But using these branching instructions, the control of the flow will be executed by using these branching instructions. It will alter the process of execution. So these are also known as branch instructions or jump instructions also. In these branching instructions, there are two types. One is conditional jumps and second one is unconditional jumps. Coming to the conditional jumps, here the conditional jumps means the jump is taken place if and only if the condition satisfies. If we are giving any condition, if that condition is true, then only the controller will move to that particular address location, which we will be mentioned in the instruction itself. So here, the first one is bit jumps. Here, it will check the status of the bit specified in the instruction. If the condition of the bit satisfies the condition, then only the control will be moved to that particular address location. So, coming to the some of the instructions or some of the examples of these bit jump instructions is the first one is JZ, jump if 0. So, here we are mentioning that jump if 0. So, what it will check? So, if JZ is mentioned in the instruction, it will check the accumulator bit, A, accumulator bit, accumulator register. So, it will check whether A is 0 or not. If the A is 0, then the condition satisfies. So, it will jump to the label or jump to the relative address which we have specified in the instruction. Let's see here, JZ, jump if 0. It will check whether A is 0. If A equals to 0, then it will jump to the location next. Here, next is a label. So, under this next, certain instructions will be there. So, controller will move to that particular instructions and it will execute that. So, coming to the next one, jump J and Z, jump if not 0. The same, but the opposite, vice versa. So here it will check if A equals to 0. If A not equals to 0, then only this condition will satisfy. If the condition doesn't satisfy, the controller will execute the next instruction. If the condition satisfies, then it will move to the specified address location. Here J and Z, if he after executing this instruction, it will check whether A not equals to 0. If A not equals to 0, then it will change to the address location. Here loop is the label over there. So coming to the next instruction, DJNZ. Here DJNZ means decrement the register, decrement and jump if not 0. First decrement the register or the operand mentioned there, then it will jump to the location. If there is no, if the register doesn't have 0, then only it will jump to the address location specified. Here the address instruction format is DJNZ, decrement and jump if not equals to 0. So it will check the register. Here RN is the register, so it will check the data in the register. Suppose the data, I am taking R2 register. Here in this I am taking R2 register. If the R2 register is having the data 2. So now, so first decrement operation will be performed. So -1. So the data in the R2 register now is 1. So now decrement R2. Yes, I have decremented the R2 and the value is not equals to 0. So what it is specifying here, decrement and jump if not 0. Yes, it is not 0. So the condition satisfies, then it will move to the location specified here. REL means relative address. So here repeat. So the controller will move to the location or the address specified by the repeat label. So next one is CJNE. So here compare operation will be performed. Compare and jump if not equal. So it will compare two operands. So here the first two operands specified will be for the comparison operation. So here the data in the accumulator will be specified by the actually byte. So directly it was mentioned. So 40H. So address is mentioned. Here if we consider this as the example, CJNE A, 40H, skip. So it will compare the two operands in the first two operands. So the data present in the A is compared with the data present in the 40H address location. So if both are not equal, then only it will jump to the location which is specified by the label. Skip. Okay. Here suppose if the data present in A is 40H. Okay. The data present in 40H address location is also 40H. Now what it will do? Compare operation. So compare. So it will be compared. So both are equal. If both are equal, then the condition doesn't satisfy. So the controller will move to the next instruction. If 40H is having the data 50H. So now it will compare both. 40 will be compared with 50. So those two are not equal. So then only the condition satisfies and the controller will move to the specified location. Here they have specified the skip. Okay. Yeah. Coming to the next one. So here CJNE, here also the comparison operation will be performed, but here the data is not specified in the address location. Here the data is specified in the hash. So hash means immediate data. Suppose let us take one example, CJNE R1. So I am taking the register R1 and comparing the data with 0AH and the location is next, or the relative address here is next. Okay. So the data present in R1. So suppose let us take the data present in R1 is 0FH. Okay. So now this 0FH will be compared with the 0AH. Both are not equal. So the condition satisfies, because what he have mentioned, compare and jump if not equal. Yes, the condition satisfies. Both the data present in the instruction are not equal. So it will jump to the location specified here. Here what I have specified, next is the label. So it will jump to the location label. If the condition doesn't satisfy, it will move to the next instruction. And coming to the some of the other examples, JC. This is also comes under the bit manipulation instruction. Here we are using single bit, which is JC, jump if carry. So if carry is there, then only jump. Okay. So here instruction JC, relative address, jump to this particular location or jump to this particular label, like that. So let's take one example. So JC If carry is there, jump to the positive. I was giving positive as the label. So it will check the carry flag. If carry flag is set is 1, then the condition satisfies, then only it move to the particular positive label. If not, the cursor then execution will be moved to the next instruction. So next one is jump if not, no carry is there. JNC means jump if no carry is there. Exact opposite. If carry is 0, then only the condition will satisfy. If carry is 1, then the condition will not satisfy. Okay. Yeah. Next one is JB. Jump if bit is specified. Jump if bit is there. So here JB bit. If this bit is set, then only jump to this particular relative. Example, I was checking the ports. So I was checking the port 1. In port 1, first bit I was checking. If that bit is 1, then only jump to the address location skip. Right? So it will check port in port 1. First bit it will check. If the bit is 1, then only it will move to the skip location of, or else it will not move to the that particular address location. It will continue with the next instruction itself. So coming to the next one, the exact opposite. If jump, if no bit is there. So the same process, if jump 1.0 is having 0, then only it will move to the skip address label. If not, the next instruction will be get executed. The next one is JBC. Jump if bit equals to 1 and then clear the bit. Suppose the same condition, let us take JB. I was checking P in port 2. Third bit I was checking. So I was writing like this, move to the label positive. Okay. So here what it will happen, JBC. So here jump if bit is there and clear the bit. So it will check if P 2.3 in port 2 third bit position is 1 or not. If 1 is there, then only the condition satisfies. So then it will move to the positive. Before going to that particular address location, it will clear the bit P 2.3. Now after execution, this bit will become 0. Okay. Jump if bit is there and clear the bit. Okay. Yeah. Next, coming to the unconditional jumps. Here the condition, it doesn't check the condition. If the instruction is having direct jump or unconditional jump, it doesn't check the condition. It will move to the, it will execute the location where specified in the instruction itself. The address we need to specify in the instruction itself, it will be moved to that particular location. Here in this 8051, we are having 3 types of jumps. Unconditional jumps. So it doesn't matter whether the condition is satisfied or not. There is no condition at all here. So it will directly jump to that particular address location and start executing from there itself. But here the thing is, we are having 3 types of unconditional jumps. The first one is short jumps, the second one is absolute jump, and the third one is long jump. So we will use these jumps depends upon the distance in the program itself. Suppose if I want to jump to the location where it is nearer to the instruction itself, like the instruction which we are specifying is about 127 bytes. So then short jump will be used. The program can jump to an instruction within if 127 bytes forward or 128 bytes backward. So if this range satisfies, then you can use the short jump. So it is also known as relative jump, because the destination address is relative to the current instruction address. So the format is, you will use SJMP, SJump. So here we will mention the relative address. So here, or you can mention the label itself, right? Next, coming to the second one, absolute jump. So here the program memory is divided into 32 pages in total. So the program memory which we are using in 8051 is divided into 32 pages. If I want to jump within 2 KB kilobytes in the page, then you can use this particular absolute jump. Within 2 KB page only, we will use absolute jump. Or else if I want to address the location more than 2 KB, like I was doing in the first page, and I want to access the data from the 31st page. So at that particular time, we will use the long jump. So using long jump, you can use all the distance from all the memory. So 8051 will support the address of 16-bit address line, so it can access the memory from 4 zeros to 4 Fs highest. So within this you can use, if I want to jump the range between the 16-bit relative address, then I can use this long jump. So usually it will be the 3-byte instruction, mostly used in the large programming. So generally we will use a jump and short jump for our simple programs. Like, let's see one example based on this. How we will represent this jump. SJMP means short jump, AJMP means long jump, absolute jump, and LJMP means long jump. So how we will mention the address? First, short jump, we will directly mention the label or address. If we want to mention the address in absolute jump, so we will mention between 11 addressing lines. So we can give 11 addressing lines over here. So like, next in long jump, we will mention 16-bit address over there. Okay. So this is how we will use the examples, how we will write this unconditional jumps. So coming to the sample program using this branch instructions. Okay. So now I was using to blink on and off port 1. So I was using one example with LEDs. So first I want to on the LEDs, and I need to give some delay, and then it will get off. So it will be running repeatedly. So how we will write the program using this branch instructions? So our program will start. I'm taking the program starting with the 4 zeros location, and I'm starting the program. So here P1 is port 1. So port 1 data is filled with all ones. So all ones, all the LEDs is on, right? So I want to give some delay. So that's why after filling the LEDs, after owning the P1 port 1, I was calling a call delay, absolute call. So what is the difference between the call and jump instructions? So the operation is same, but the thing is, if we are calling the delay, so the delay label, what is the instructions present in the delay label will be executed once over here. Okay, after that the cursor moved to this particular location, right? Next location. But if we are using jump, the instruction, the controller will start executing from that address itself. Okay. So now if we are using a call delay, so this particular set of instructions will be executed here in one time. So here what I have mentioned, so move R2 comma 20. So R2 is filled with the data 20. Let's say this is the outer loop. So next to loop 1, in loop 1 I was taking R1 as 250, right? No operation means it just wastes the time. It just kill the time. That's it. So one no operation is there, just kill the one clock cycle. Next, moving to the next instruction. So here decrement, as already we saw, decrement, and if jump if not 0, I want to decrement the data present in the register R1. If the register, after decrementing, if the register R1 is not having the 0, then only again move to the loop 2. So now what is this? R1 is having 250. So after executing, it will get decremented and it is having 249. No, it is not equals to 0. So now the condition satisfies and it will move to the location loop 2. Here what is loop 2? Again this internal loop will be executed unless it will get 0. Next it will get 248. Like that it need to get 2 and 1 and 0. If the condition, if R1 is having 0, then here what I have written? Decrement and jump if not 0. So here decrement operation, after 1 it will be decremented to 0. Jump if not 0. But here we are having R1 as 0. So the loop will not execute. So now the next instruction will get executed. Here what I have given, here also decrement jump if not 0 for the register R2. Now this outer loop will get executed. So 20 will decremented and become 90. So the condition will not satisfied. So what I told, loop 1 again R1 is moved to 250. So this will be repeated until unless. So some sort of time it will get executed, and then condition will get back to here. What is this? Move P1 0 0. So until unless this loop executes, the P2 P1 bits are always FF, like it is on. So after executing, after providing some sort of delay, the P1 will now refilled with 0 0. So the LEDs, all LEDs, glowing LEDs will be off. So on and off will depends upon this instructions itself. Okay. So until now we have discussed the branching instructions and what are the different types of branching instructions: conditional branch instructions, unconditional branch instructions, jump instructions, and thank you.